Hello, 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 and welcome back, everybody. I hope you're having as good a time as possible. I hope you're staying safe, washing your hands, and everyone is all right. Welcome to week 5 of FOT. Let's go ahead and talk about what we're doing this week. But first, a quick check-in. What have I been up to? I am ashamed. But I do have this really neat boat. Look at that boat. It's really large. It's in the sky. And you can come over here past all these sheep. They're happy. Don't look at those sheep. They're happy where they are. Don't question it. Over here we have a little lift. You can ride it all the way up into the belly of the ship. Yeah. I miss school. Anyway, let's talk about actual learning stuff here, because that's why you're all watching this video. What are we doing in this class? So we're going to be applying Ohm's law. We'll talk about what that is. We're going to be differentiating among voltage, amperage, and resistance. You should already have done that, but I'll go over it again. And we'll talk about parallel and series circuits. All right, so voltage. When you think voltage, think pressure, right? It's the electric difference in potential energy between 2 points. So if point A is really, really positively charged and point B is negatively charged, the electrons want to get from the really, really negatively charged area to the really positively charged area. And that electron flow is then going to be what we call electricity, really. So you have to have voltage before you can have any kind of flow. And the more voltage you have, the more flow you can expect, right? Amperage is then actually measuring that flow once it happens. So an amp is literally how many electrons you're going to see pass through a given point per second. And 1 amp is about 6 quintillion electrons a second, which is quite a bit, right? And this is what you would be seeing. You'd be seeing these little particles, if you could see that small, just rushing by. Be a lot of them. So it's a large amount of electrons flowing through a given area, and that actually is what makes all of our gadgets work. Resistance is kind of like the size of your pipe, if you go back to that water analogy, right? So if you think of voltage as your water pressure, amperage is actually how much water is flowing through, resistance is the size of your pipe. The larger your pipe, the more electrons can fit through all at once. The less resistance there is, the higher amperage you can have. So 1 ohm, which is what resistance is measured in, represented by this Greek letter omega here, corresponds to the amount of resistance you would need, so the size of your pipe, if you think about it that way, to have 1 amp, so 6 quintillion electrons per second, if you have the potential difference of 1 volt on either side of that circuit. So, pretty abstract stuff to think about it, but you can just imagine the more resistance you have, the thinner your pipes, the less electrons can fit through, or the fewer electrons. So then there are 2 ways we can kind of set this whole thing up. We could have a series circuit or a parallel circuit. If you're going to have a series circuit, then everything is going to be in line. So this is my battery over here. It's 9 volts, has a positive end and a negative end. Positive end is usually represented by this long line, and the negative by this short one. And conventionally, we say electricity flows this way, although in reality, it actually flows this way. For figuring out a circuit, it doesn't really matter. I will be using the conventional speak of electricians, not physicists. Physicists would say it's the other way, of saying the particles are going this way, even though that's technically incorrect. So as electricity is flowing through our circuit here, it's passing through these resistors. So as it hits this first one, a resistor is really any component that uses electricity. It doesn't necessarily have to be a resistor. So like a light bulb is a resistor because it's using up some of that electric flow to do some kind of work. So if you look at this, we first have to pass through this resistor, and then through this resistor, and then through this resistor. There's no choice. We're going through a series of them. So it's a series circuit. A parallel circuit is one where the electricity has options. So as we go down this wire, the electricity could go this way across this resistor and then back to the source. It could instead go this way, or it could go this way. Now, both of these kinds of circuit have interesting properties that we'll be looking about next week, so stay tuned for that. But before we do that, let's talk about Ohm's law. So if we take a look at Ohm's law here, Ohm's law is going to be kind of the foundation, the bread and butter. Really want to understand how this thing works in order to do well in the following assignments. And it's real straightforward, nothing crazy here. All it says is your voltage is equal to your current, I, times your resistance, R. So I is going to be measured in amps. That's how much current you have. R is going to be measured in ohms, is your resistance. And V is pretty easy. Voltage is measured in volts. So let's try a couple of examples. If my TV measures 2 amps on the inside, so that would be 2 is the I here, and it's plugged into the wall socket, 120 volts, 120 goes right here, then what is the resistance across the whole television set? Well, if we try that, let's see. What we're trying to say is 120 is equal to 2 times R. We don't know what R is, but could we find out? I think you guys could figure that out, right? If we divide both sides by 2, you're going to get 120 divided by 2 is equal to 2 times R divided by 2. And here, the 2's will cancel out. So you're going to get R is equal to 120 divided by 2. Let's pull out our nice calculator here. 120 divided by 2 is 60. Bam! And this is 60 ohms, or you can use the Greek letter omega to signify that. Awesome. How about this one? I know my microwave has a 200 ohm resistor in it. Plug into a wall of 120 volts. What amperage can I expect to measure inside? Well, same idea, but we know slightly different things this time. We know 120 is going to equal to some I, measured in amps, we don't know what that is, times some R. Well, R here is 200. And they're multiplied together. Easy. What should we do? Well, same process applies. We just divide both sides by 200 this time, since that's the coefficient we have in front of the variable. So let's try that. 120 divided by 200 is equal to I. So I is equal to, well, 120 divided by 200 is 0.6. So I equals roughly 0.6 amps. There you go. That is going to be the foundation of most everything that you see going forward. All right, so now that we have a quick overview of Ohm's law, what are you guys actually responsible for doing for me? You're going to watch a couple of videos and answer some questions and do a couple of calculations using Ohm's law. Everything can be found in week 5 Ohm's law assignment posted under modules. If you have questions, please email me. And I'm also available for Zoom meetings if you would like. Here's the assignment. Under modules, it's posted just like every other assignment. If you open it up, there are a couple of things to note here. There is one video for you to watch and answer these basic questions. Then there are some calculations for you to do, you'll need a calculator. Here's an online one you can use. And lastly, there's one more short video to watch on circuits and answer these questions. Hopefully that's not too much. Let me know your thoughts and stay in contact. Have a good rest of your week, guys. Take it easy.